Bienvenidos, Ushamdi, and welcome CMIT 454, sections 6380 and 6382 for the first 8-week term of the spring 2018 semester at the University of Maryland University College. This is the Cisco Networking Academy CCNA Security version 2.0 course, and this afternoon's packet tracer tutorial and solution set is going to be on zone-based policy firewall, or ZPFW, as you will commonly see it referred to. Now, this is sort of going to be the culmination of our conversation on the iOS security firewall. In other words, when we transition to the ASA, we're no longer talking about it in the context of putting a firewall on a router. We're talking about actually running a firewall device. And so this is sort of the culmination of our conversation on the standard ACL, the extended ACL with the established option, the TCP intercept, the reflexive ACL, and then the previous video to this, which was the context-based access control, or the CBAC inspection engine, commonly referred to as the classic iOS firewall. And so remember that the reflexive ACL was the first sort of attempt at a stateful firewall, and this was after we did the extended ACL with the established keyword. Then we kind of went to the reflexive ACL, and then the reflexive ACL kind of spawned the context-based access control CBAC, classic iOS firewall, and the current version and the best practice is to currently deploy the zone-based policy firewall. So let's jump in, and this is a fantastic activity from the Networking Academy, activity 4411. So let's dive in here and take a look. And it's going to definitely give us a nice soft landing into probably one of the more confusing topics for some learners, especially if this is your first exposure to iOS firewall technology. So we've got our objectives up here. We're going to verify connectivity before the configuration, right? So that we can prove that it is being protected or it's doing what it's supposed to do. We're going to configure the zone-based policy firewall. We're going to do it all on router 3 right here. And then we're going to verify the zone-based policy firewall functionality with ping SSH and a web browser. All right, so there are our passwords. So what do we have? Cisco ConPass, VTYPA, and ENPA, and then we've got some usernames, which I'm sure I'm going to have to come back to at some point. So let's get in here. Let's verify basic network connectivity. So we're going to go to PCA, which is the server here, and let's pull up the command prompt. We'll go to the desktop. We'll get the command prompt up, and let's verify, can we SSH over to 10.2.2.2? And we can. The session opens up. We're asked for a password, and it's going to be admin, and I believe this is correct. Oh, I'm sorry. Admin PA 55, and there we are. So as you can see, we're on to router 2. So SSHing from PCA to router 2 works. And what are we going to be doing next here from PCC? So we'll close that down. From PCC, let's open up a web browser here. Go to our desktop, open the web browser up, and let's say HTTP:/. And what are they looking for? Enter the PCA IP 192.168.1.3. And there we go. Welcome to Packet Tracer 6.x, the best thing since Packet Tracer 5. And actually, we're using Packet Tracer 7 for this activity. So Packet Tracer 7, and specifically 7.1, is the latest release. Okay, so we've got that squared away. So we've confirmed SSH connectivity from A to C. We've confirmed web browsing capabilities from C to A. And now let's go ahead and close this down here. All right, so here's what we need to do. So now we're kind of, this is where the rubber meets the road. And this is a very important step. This command right here, this license boot module, what this does is this is going to activate the security license and feature set on router 3. And the reason that this is important is because without that security K9 technology package, you cannot run zone-based policy firewall. So we have to have that license installed, and this is specifically on the ISR G2s and some of the G1s, I believe. But we've got to have this command. If we don't have the license, we can run this command, and it's going to let us use the security feature set, and that's why they call it the right to use, for a limited amount of time, at which point it'll continue to work, but you'll start to receive log messages if you go outside that sort of probationary experimental period, that temporary period that they give you. And I believe it's 60 or 90 days. So let's go ahead, jump onto router 3 here, and let's activate our security license. And again, very important that we remember this step, because if you were to jump onto router 3, if you were to jump onto router 3, which I think is Cisco Con PA55, is it capital C, Cisco Con PA55? And I swear I thought it was Cisco Con PA55. Cisco Con PA55, it is. Cisco Con PA55. All right, there we go. I thought I'd type that in the first time, or the second time there. All right, so let's get the license installed here. So we'll go from user exec with the enable command to privilege exec mode, where we now have to type in Cisco En PA55 to get into privilege exec mode. And let's see if this, good, the command is supported. So the show license command, very important. Do they have you run that? It doesn't look like they have you run this, but here's why you want to run this. And that command by itself on real Cisco iOS, in fact, let's make that happen. On real Cisco iOS, and what do we have here? Let's go to router 11. And this is a 1941. We'll give ourselves a little more space with which to work. And we'll say no, and actually, we'll just go to router 12, which I already know has a prompt here. So we'll go to privilege exec mode. When I say show license and hit enter, it always pauses for a second. It's generating a quick show here of what type of licensing you have and what is activated, right? So this is the IP base license, and this is what allows me to do my routing protocols, right? My OSPF, my EIGRP. And here is the security K9. Now you can see that I've purchased and applied the security K9 license. So it has a lifetime license, and that's how the licensing works in the iOS scheme, is that you purchase a license, you apply that license, you can see it's a permanent license. If it wasn't permanent, if it was a right to use, it would say right to use here. And probably one of these routers I have will say that, but I just don't know which one. So, but again, it says permanent, which means the license has been paid for and it's been applied. But that show license command is very important. If you move on in your Cisco studies, if you wanted to do MPLS, you would need the data K9 license in order to run MPLS. And as you can see, good, okay, here we go. You can see I've applied that in a right to use fashion because I did not purchase that license with the router. So after the, I'm saying probation, but there's a better word for it. After the temporary, or the eval, after the evaluation period, that's what I'm looking for. After the evaluation period, it doesn't disable the functionality, but it's in sort of your best, I don't want to say your best interest, but the right thing to do is to then purchase the license and apply the license. That's the right thing to do. Although it doesn't stop working, again, you should probably pick up that license. And you can see here that the eval right to use has been set up on a number of those features there. All right, so back to the command line. So show license, that is the command that we are interested in. And let's get back to the desktop here. That's the command that we are interested in. Let me see what the packet tracer has. Okay, so they just want all detail feature. So we'll say feature, and then let's see what we've got. All right, so that's another way to take a look at it. And here is the security K9, right? And as you can see, enforcement, yes. Eval, yes. So it looks like the eval's already on. Here's one way we can check this, is we don't enter that command. We don't say license boot module C1900. And after you apply that command, this is also very important, is that you must reboot the router, right? You got to reload the router after you're done there. So let's go ahead and we'll get into global config here. and we'll say zone security, and you'll notice, right, security, and I'll just say test. And you can see how it's pretending that it doesn't know what the zone command stands for. And that's because the license hasn't been applied. We're not going to have access, just like with AAA. Think of it as the AAA commands. We don't have access to the AAA commands until we do what? Exactly. Until we say AAA new dash model. So when we say AAA new dash model, that is when we have access to the AAA command set. And the same thing is true here. With the zone-based policy firewall, we won't have access to the commands that we need in order to configure that until we apply that license, right? Or we activate the right to use. So let's do that right now. So let's say license boot technology, module C1900 technology package. And if I do a question mark, the only one here, and this would make sense, right? We don't need the collaboration or the voice license because this isn't a voice or collaboration course. We certainly don't need the data K9 because we're not doing any MPLS. That would be sort of a CCIE routing and switching conversation. But we do have access to the security package, right? The security K9. And now we receive the right to use. And what is it 8 weeks? I think maybe it's 8 weeks. I think it's 8 weeks here. Well, it talks about 60 days. I could have sworn it may have been 8 weeks on real iOS, but we're going to accept that. We're going to say yes. Now, take a look at what it says. We have to use the right command to make the license boot config take effect on the next boot. So let's go ahead and go to end. Let's say write mem and reload. And we'll confirm. And the nice thing is that this isn't going to be a 3-minute waiting period here, which is typically with the ISR G2s. That's about how long you're going to wait when you reload one of the routers, like a 1900 or a 2900. And you can see here, it was all of about 10 seconds. So let's say Cisco CONPA55. And then we'll go from user exec to privilege exec with the enable command, Cisco ENPA55. So we're back at privilege exec. So let's say show license all. And so here we go. Where's the security K9? So you can see the eval period. And this one here is showing 208 weeks. I think with real iOS, it's closer to 8 weeks. So, but we've definitely got a nice evaluation period with which to sort of, kick the tires and see if we like the features. And the data K9, even though it wasn't a selectable option, it shows up here for some reason, right? Okay. So we've got our license, and now what that means is we can configure our zones. Well, let's take a look. Before we do that, let's take a look at the topology here. Because remember, when we talked about CBAC, or context-based access controls, those were a huge improvement over reflexive ACLs. Now, one of the significant differences is that CBAC, and let's see if my pin's going to keep up here, CBAC, there we go, is interface based, right? Which means we applied it onto the interface with that IP inspect command, right? We said IP, and that's a terrible P, IP inspect. And that's how we applied CBAC. Now, with zone-based policy firewall, this is a zone-based model. So we aren't actually going to be applying it interface by interface, or the interfaces don't stand on their own. They become members of the zone, right? And so this gives us much more scalability than if we were to use the CBAC approach. And here's what I mean by that. So let's pretend that router 2, right, is our inside router, and here's our network behind it. Now, if router 2 is the inside network and we've got CBAC applied here, if we go to grow the network, and let's say we decide we're going to put up a DMZ, right? So now we need another inspection policy here if we wanted to allow CBAC to work there. But the question is, well, what about traffic from the, let's say this is our inside here. we know we're dealing with traffic inside to outside, right? Because we've got ACLs out here and the traffic's being inspected. But what about inside to DMZ? How would we approach that, right? Well, see, that's where it starts to get a little trickier. And this is one of the drawbacks with CBAC is it doesn't scale very well, where zone-based policy firewall does, because instead of the interface having the inspection policy, the interface is simply a member of a zone. And so we can put multiple interfaces into one zone. So if I was to clear this, and let's say that, that this is the internet now, right? So if this is the internet, and this is my inside network, right? So we'll say this is the inside network here. I can put both of these interfaces into the inside zone. And then whatever policies we have defined for the inside zone would apply to both of those interfaces. And in fact, since those interfaces are in the same zone, we then implicitly would be allowing intra-zone traffic. So in other words, if these guys are part of the inside zone and these guys over here are part of the inside zone based off of this membership here, then 192.168.1.3 can talk to 3.3 and vice versa because it's intra-zone traffic as opposed to inter-zone traffic. So a few things to remember there, right, is that zone-based policy firewall intra-zone communication is allowed by default. Inter-zone communication is not, right? Is not. Okay, so let's continue on here with our zone-based policy firewall. And so the first thing we need to do is we need to determine what interfaces are going to be members of which zones, right? Or basically, what are the requirements that we have here? Well, remember, we're dealing with router 3. So the way to look at this, and I'll do it like this, is that this cloud over here, this is the inside, the trusted network, right? And everything else out here is outside, untrusted. Outside and untrusted. So this is, and this is appropriate, right? For the CCNA level, this is the appropriate entry point for a conversation with zone-based policy firewall. We have a single inside interface, and we have a single outside interface. And so this is going to give us a very straightforward approach with which to have the conversation about zone-based policy firewall, because we're going to be going from the inside to the outside, but we are not going to be allowing initiation of traffic, or I should say just any traffic, to come back in. Now, remember what we said when we talked about context-based access control, is that the inspection engine is the exact same engine zone-based policy firewall is using. They're using the same inspection engine. In fact, we'll see that when we get into the class maps and the policy maps. You'll see that when we go to pick the type of traffic that we're going to inspect, the exact same options that we saw with CUCME or with HTTP and HTTPS and Telnet, that those are all there, as are generic TCP and UDP, right? Those things are still there as generic. So again, it's the same philosophy where we're picking traffic to be inspected when it hits router 3, and then as traffic returns back, there's going to be a state table here on router 3 that will be referenced to determine, is the return traffic allowed to come back through? Or if there is no state table entry, do we drop the traffic, or is the traffic going to be allowed to come back through? So let's clear the screen here. And now that we know the requirements, right? We've got the inside interface and the outside interface. Now we go ahead and we create the zones that we're going to be using. And again, very, very straightforward. And let me lower this just a skosh there. Very, very straightforward activity here where we get into global config, and I'm going to say zone, whoops, not zone member, sorry, zone security, and they want us to call it the in-zone for inside zone. And this is arbitrary. You could call it production. You could call it inside. You could call it anything you want. Trust, right? It's up to you. But definitely make sure that it's something meaningful, because as you'll see, when we go from the zone name to the class map name to the policy map name, it can become a little confusing very quickly if you don't keep the names straight and you don't keep them meaningful. So, zone security in zone. And you can see that we're presented here with sort of a sub configuration where all we can do is exit. Now, this is not the case with real iOS. There's an option to put a description in here. And it's always a good idea. Maybe you put down the date that this was created, who created it, and maybe the change control number, right? Or something that describes the zone so that individuals that are following you at your company have an idea as to what's going on. So I'll just say exit, and then I'll say zone security. And again, we haven't applied anything yet. So these two commands are innocuous, right? By themselves, this is meaningless, right? This doesn't really do anything other than set up the framework for us to go forward with the zone-based policy firewall. So I've got my two zones created. I've created the inside zone and I've created the outside zone. And we're pretty clear on which interfaces these are going to be applied to. So now we're going to identify the traffic. Let's scoot up a little bit here. Whoops. We're going to identify the traffic using a class map. Now, this is typically where new learners will become confused with the zone-based policy firewall approach and syntax as compared to context-based access controls. Remember, with the context-based access control, and as just a real quick review here, I'm not going to do much of anything other than get into global config and say IP inspect name, and then if we were to say inside, right, and then here's where we pick what we're going to do, right? And this super easy. And I will definitely say and agree if you're thinking to yourself after you see this zone-based policy firewall that, wow, CBAC was way easier to configure. I agree with you 100%, especially if you're not familiar with the class map and the policy map setup. It can be a little overwhelming, but we're going to break it down and make it nice and easy to understand. And so again, like if I wanted to do generic TCP, there we go. And then I would go to the interface and I'd say IP inspect, inside, in, done, right? So CBAC, super, super easy. However, it was limited. Remember, it was an interface-based model. Now we're talking about a zone-based model. And again, it gives us more scalability, but that scalability comes at a cost, that being the simplicity with which we configure zone-based policy firewall, as you're about to see here. So we're going to create an ACL that defines internal traffic, because one of the things you can do with zone-based policy firewall, in fact, I'm looking at this right now, and this is sort of my first glance at this activity, is I'm definitely going to do a supplement to this where I'm going to build a little bit on, I'm actually going to build quite a bit on what they've got here, because I want to make sure I give you a good set of data with which to work and see to hopefully clarify your understanding, because you don't have to use ACLs. You can, and there's nothing wrong with that, and that's what we're going to be doing here. But there's also other ways to deal with the zone-based policy firewall. So let's go ahead and say access list 101 and permit IP 192.168.3.0. So again, really, 0.0.0.255 and any. So what are we doing here? Again, this is going to be the statement that we use in the class map. And it's very important to realize the class map. This is the way I think about it, the mnemonic I use to remember. What does the class map do? The class map classifies, right, or defines the traffic we want to inspect. So this is how we say, because like on the other screen there, when we said IP inspect name inside TCP, the class map is how we define what it is we want to inspect. So think of the class map as classifying the traffic we're interested in, the interesting traffic. And that's how you would do it with CBAC. Here's how we're going to do it with zone-based policy firewall. So we create an ACL that basically says all IP traffic from the 192.168.3.0/24 that's coming from that network going anywhere. That's the traffic that we're interested in. And you can see we're basically going to be saying it's going to be traffic that comes in on this interface right here as a member of the in-zone, the inside zone. That traffic will be matched. And what that means is that state table connection entries will be created so that return traffic can now come back from the outside zone. So let's get this entered in here. So we say access list 101, permit IP 192.168.3.0, 000-255 any. And as I'm reading that, I'm kind of looking up here and I want to scroll down a little bit. So again, it's the class map. So and this is the syntax to do this. As you can see, it's a little more complicated. So I'm going to say class map. Type in now. Quick note here. Let me see if they leave it open here. Okay, so they don't. Now this is very, very important. You'll hear this term modular quality of service, right? Or the MQC, right? Modular quality of service command line interface, MQC. And that's the syntax. When you see this class map and policy map, that's MQC, right? That's what it's referred to as modular quality of service command line interface. Because when you go to configure quality of service, you use MQC. In fact, you use these exact same commands with the exception of the type keyword. So here's what I'm trying to say. And be careful of this on real Cisco iOS. So here I am on router 1. If I was to say class map and do a question mark, you can see that we end up with word, match all, match any, and type, right? So when I go to say type, that's when I get to pick inspect. If I don't say type and I simply say class map, and let's say that I went like this, in zone, that I was going to create this class map and say in zone. When I hit enter, it's acting like everything is fine because iOS thinks that it is, but what iOS is interpreting your command to tell it is that you want to configure QoS, quality of service, that you're not configuring zone-based policy firewall. So remember, you have to say class map, type, inspect, and the same is true of policy map. If you don't say type inspect, iOS is going to interpret and parse those commands as if they were QoS commands. So make sure that you remember that. And as you can see here, we could also put in class map, and I could say put the word in, and it's going to think it's a QoS configuration, not a zone-based policy firewall configuration. So here we go. Class map, type, inspect. And now we get to these two keywords here, right? Match all or match any. And when we look up here, you can see that we've selected, or we're going to be typing in, match all. So the question I know that you've got to have right now is, what is the difference? And it kind of spells it out right there, but let me make sure I clarify that when it says match all, what that means, and let me get my pen back here, what that means with the match all, it's a logical and, which means that everything that you list would have to be true. So if I said match TCP, or if I said match all TCP, UDP, and ICMP, we have a problem here because this would mean that the traffic, right, would have to meet all three of those criteria in one fell swoop. And the traffic cannot be at the same time. It can't be ICMP, UDP, and TCP, right? It's going to be one of these three, but like when I run ping, right, we're doing ICMP for our, here, we'll do SSH, easier to spell out there. When I do SSH, right, SSH is using TCP, which means it's not UDP and it's not ICMP. So then if I said match all and put those three in there and I went to SSH, it is not going to work because SSH is not TCP and UDP and ICMP. So it's not going to work. It would fail. And that's something to keep your eyes out for exam-wise, is that little keyword right there is very tricky, because what you might see is they say match TCP and then UDP and then say, will the SSH session successfully connect? And the answer would be no, because if it's match all, that would mean that that SSH session would have to be both TCP and UDP based, and it is not, right? What you would be looking for is a match any when you're using multiple protocols or applications. And remember, zone-based policy firewall, just like CBAC, does that deep packet inspection. It goes deeper into the packet because, again, we're using the same inspection engine. So it can go look at that layer 7 information, and it works very, very well with those non-standard applications like a passive HTTP, I wanted to say passive FTP, or voice traffic, right? Where you're going to have randomly high source and destination port numbers that are very difficult to pin down. So we're going to say class map type inspect, and we're going to match all, which means this is a logical AND. Now it says the word of the class map name. Well, that is simply going to be, and I'm reading this here, it's tough for me to see, so I don't have my glasses on. So we're going to say in-net-class, and as you can see, this is something meaningful, class-map, right? What you wouldn't want to do, and what would be, it's sort of the kiss of death, is if you were to say, you know, class map 1, class map 2, class map 3, you know, and for your zone, if you said zone security, zone 1, zone 2, zone 3, when you go back to look at that, or more frighteningly, if someone following you at your company goes back to look at that and you're gone, they're not going to have any idea what's going on, right? So definitely choose meaningful names, not just for yourself, but also for people that are going to follow you. All right, so we're going to say class map type inspect match all in net class map. All right, and now that that is done, what are we going to match? What traffic am I interested in? What's the interesting traffic that I want to inspect on router 3? Well, we defined that when we created that ACL. So I'm going to say match access group 101 because that's the access list number that we use. Now, you can use an ACL, and we see how to do that, and it's right there. But take a look. I can say match protocol, and take a look at all those protocols that I can match. So TCP would be your generic TCP. HTTP, right? And there's the H323, the FTP. You can even do EIGRP, right? And BGP. And where's UDP? Oh, this is at the very bottom here. And there's UDP, User Datagram Protocol. So if I wanted to just simply say, only allow TCP outbound connections, right? Only inspect TCP outbound connections, I would say match protocol TCP. And again, when I do my supplement to this, you'll see that, and we're going to be taking a look at the match protocol statements. But here, we just want to say match access group 101, and that's going to match all traffic. Because remember, when you have IP in the ACL, when we said access list 101 permit IP, we are saying all traffic. IP is a blanket umbrella statement that says everything. No matter what the traffic is, the IP matches it, right? So match access group 101, and now we're going to exit. So step 1, right? What was our first step? We activate the license, technically, but once that's done, the first step is we go ahead and figure out which interfaces are going to be in which zones. We come up with how we're going to set it up. Then we create the zone security statements. We create the zones. Now we create the class map that's going to identify the interesting traffic, in which we know is going to be all traffic coming off of the LAN 192.168.3.0/24. So now that that's done, now we're going to specify the policy as to what we want to do with that traffic. So this is where the policy map comes into play. And again, the same is true. If I said policy map ABC and hit enter, that is not going to be interpreted by iOS as a zone-based policy firewall configuration. It would be interpreted as being part of some QoS config that you're doing for quality of service work, right? So remember, it's always type inspect, right? Type inspect. So we say policy map type inspect, and again, we've got another name coming here, and you can see where this can get a little confusing and complicated. So we're going to call it in-2-out-policy map, right? So it's in to out. That's going to be, it's basically in to out policy map. So what do we want to do with the traffic that we're matching? And here's where we say class type inspect. And this is where we reference the class map, right? So we create the class map, and that's where we say, this is the traffic that we're going to capture. This is what we want to match. And the policy map is, what do you want to do with all that traffic that you're matching, right? So we say class type inspect, and we reference the in-net-class-map. And if I roll back here just a little bit, you can see in-net class map. So this was the name of the class map we defined, where we said, yeah, I want to match all traffic that ACL 101, the extended ACL 101 is going to match. Now in the policy map, we refer to the class map, right? And it's right here where we determine, right here, what are we going to do with that traffic that's being matched? Are we going to drop it? Because we could certainly drop it if we wanted to. Are we going to inspect it? And take a look at that. And this is very telling, right? Because if you were kind of a little, skeptical at my statement that zone-based policy firewall is using the same inspection engine, take a look right here. When we put the inspect keyword, which is what we're going to put, it actually tells you it's the context-based access control engine. We are using the exact same engine. It's just that the syntax, as you've clearly seen so far, is very different. Very, very different. Okay, and then finally, we could pass the packet or pass the traffic. And what that means is I want to allow it to go, but I don't want it to be inspected. Which means if that traffic was to come back, right, there's no inspection session for that traffic. So we want to inspect the traffic, and this is where we put that keyword. So it says, no specific protocol configured in class in-net class map for inspection. All protocols will be inspected. But remember, we've got the ACL there, right? Which is basically saying match everything. So all protocols being inspected, that's what we're asking for. We're asking for all protocols to be inspected. Okay, so now we say exit and exit. And I'm looking here. All right, so now we're going to apply the firewall policies. So we need to create zone pairs. And again, another significant difference, another significant step that's required with zone-based policy firewalls. Because I need to say, which interfaces am I pairing up here? Am I going to say it's, inside to outside? Or is it going to be, outside to DMZ? Maybe it's inside to the partner zone if you've got a partner zone. But here it's very straightforward, right? We're talking about inside to outside. So let's create our zone pairing. So we're going to say zone pair security in to out Z pair. And the reason I'm laughing is because I find the names kind of odd. Not names I would have chosen, but definitely good names. And here's where we say, which zone is the source zone, right? And we know that that's our in zone. And what is the destination zone? So here's the pairing. This is where I say the source zone is this zone, and the destination zone is this other zone. So the zone-based policy firewall now knows which zones are paired together, and now we're going to tell it which service policy, and you'll remember this is going to refer, and this refers back to the policy map. So it's kind of like the movie Inception, or it's like it's like a dream within a dream within a dream. So you've got the zone pair that we just created here that refers to a service policy, right? That policy map. And then the policy map refers to the class map. And the class map is matching traffic that refers to the ACL. So it's like sort of this interwoven tale. And again, you can see what I meant when I said typing IP inspect name inside TCP and then applying that is a lot easier than this. However, the syntax for this, as hopefully you're seeing here, is much more complicated. So service policy type inspect into out-pmap, right? And that, oops, sorry, I got a typo in there. And that was the policy map that we created that referred back to the class map telling us what we're going to match. So this refers to the policy map that defines the action we're going to take. What are we going to do with the traffic that we match? And then the policy map refers to the class map, which is all about, well, what traffic are we matching, right? And that's where that ACL came into play. So let's go ahead and hit enter here, and then we're going to say exit. And the final step is we're going to assign the interfaces to the zone, right? So it's here where we assign interfaces to zones. Now, a key point to note here is that when we're talking about assigning interfaces to zones, an interface with zone-based policy firewall, an interface can only be a member of one zone at a time. So in other words, we're going to be using the gig 001 interface here. So let's knock this out. So gig 01, and I'm going to say zone member security and the name of the zone that this interface is a member of. Now, if I was to go to interface gig 00 and say zone member security in zone, or I'm sorry, yeah, don't want to do that. I got in the wrong interface there. If I was to go into interface gigabit Ethernet 01, whoops, and try to say zone member security out zone, I can only be, it's one or the other. So when I say do show run, right, you can see it's a member of only one zone at a time. So I can't put the interface into multiple zones. You can't do that. So let's get our points back here by saying zone member in zone. And then let's get an interface serial 001. This is our outside interface. So zone member security out zone. Right? All right. So that completes the configuration portion. So let's take a look at what we have right now. And again, once you do it a few times, it's not that bad, right? It's not that bad. And again, it is far more flexible. I'll talk about the self zone in the supplement. And the self zone is that zone that I referred to that by default allows the control plane traffic, or it addresses the control plane traffic. So let me get this done here. We'll say show run. And there's our license boot showing that we've got our technology package. So what do we have first? We've got our class map, right? It says match access group 101, which is the ACL. So we define what traffic we want to match. What are we interested in inspecting? And then we define the policy map that says for the traffic that I match in the class map definition, what do I want to do with that? Remember, we could drop it, we could pass it and not inspect it, Or, as we're doing here, we can inspect it. And then we had defined our security zones, right? We have an inside zone and an outside zone. And then we paired the interfaces together. And remember, this is actually extremely important as well. This relationship, this zone pairing relationship that we're looking at, this is a unidirectional relationship. So if I wanted traffic that was originated from the outside zone to come to the inside zone, and again, that's different than traffic going from the inside to the outside and back. I'm talking about traffic originating in the outside zone, and we want to allow that through into the inside zone. I would need to create another zone pairing. And it would basically reverse these statements that you see here, where the source would be the out zone and the destination would be the in zone. But that's a very critical point, is that these zone pairings are unidirectional relationships. It's a one-way relationship. So what I've defined here is going to allow me to originate traffic from the inside zone and go to the outside zone and then come back because we're inspecting it. This does not mean that I can originate traffic from the outside zone and then expect that that's going to come in, because it's not, right? It's not, because we're not explicitly allowing that to happen. Okay, so, and I think that's all we've got here. And then on the interfaces, right, we put each interface into its respective zone. There's the in zone and the out zone. We have our ACL there at the bottom. All right, now let's do some confirmation here. So from internal PCC, can we, what are we doing? Are we pinging? Yeah, we're going to ping. So let's ping that external server, 192.168.1.3. Now, will this work? Yes or no? Absolutely, because remember, the access list was matching all protocols. When we say IP, we're saying all protocols. Now, maybe we've got to wait for an ARP request, and then we've got action. Right there we go. Fantastic. So the ping works. Let's take a look at, and let me see if they've got the command. So show, and it should be, no, it should be show zone, or show, I'm trying to remember policy map. I think it's show policy map, type, inspect, there we go. Zone pair and sessions, here we go. So we want to examine what's going on, right? So here we go. Show policy map, type, inspect, zone pair, sessions. And again, as you can see, it's a little more involved than the CBAC syntax, right? But here's where we see, all right, what's my zone pairing? It's inside to outside zone pair. The service policy, right? It shows me the in to out policy map. And then here's my class map. And then we've got this default. Oh, I'm so glad I ran this command because this is another important piece of information here. So take a look at this implicit, right? It shows up here, but did we create that? Which is basically match any drop. No, we didn't. And that default class, that default, the class default statement in the class map, think of that as your deny IP any, because there it is at the very end, and it's going to drop all traffic that doesn't match this ACL. Now, what we're doing here is we're matching everything anyway with this ACL, so nothing is going to hit the class default at this point. But you could run into scenarios where if I only wanted to allow TCP, UDP, and ICMP outbound, right? Or let's just say maybe you only want to allow TCP, that UDP traffic would hit this. ICMP traffic would hit that default, that class default statement, and it would be dropped, right? Okay, so there's also, I thought there was like a detail that we could get on that. Okay, so that's that command there that allows you to check out the configuration. And then what else did it want us to do here? It says from the internal PCC, SSH to the router 2 interface. So we're going to say SSH minus L admin, and that's a capital A, I believe, admin, and 10.2.2.2. So there we go, and it's going to be admin PA55, and now we're on router 2. So SSH works, and actually, there's the command is right there. I couldn't remember the command, and it's right there. All right, so let's go back and take a look with the SSH setup, and we should see, right? Why didn't we see those ping packets? And there's no repeat option. I can't do a, or actually, let's see if the -T is here. Let's see if the ping -T works. All right, so the -T looks like it's working. If I rerun this quickly, there you can see the ICMP. Now, this should look very familiar as well, because we saw this exact same information. And take a look at the detail. It tells us it's an echo request, right? And it knows who it's going to and who it's from, and it knows it's the ICMP. So it shows me the conversations that are taking place, right? And again, this is my from, and this is the to. Okay? And it still gives us really, really good information about what's going on. And one session is established. And we would see the same thing if we were to do that SSH command again. And you can see that this is continuing on here. So if we ran that SSH command again, and I said admin PA55, we're logged into router 2 through router 3. So when I say show policy map, type inspect, zone pair sessions, take a look. Now, you're probably wondering, well, wait a second, why is the ICMP still in there? Because the connection table is going to keep that session in there for, I want to say it's like 5 seconds. It's a very brief amount of time. And then it removes it from the state table, right? So even when it stops, it's still going to be in there for a few seconds, and then it pulls it out of the state table. But here we see we've initiated TCP, right? And you've got the session open, and we've got some information here about bytes sent, initiator, and responder, how much traffic is being sent back and forth. So good information to have. Finally, we're going to do a web browser, and let's go to the desktop again and pull the web browser up, and this also should work, 192.168.1.3, and it does, right? We get the small page, we get the copyrights page, with all the Cisco copyright information. And I'm assuming that they're going to want us to test firewall from the out zone to the in zone. So verify the external host cannot. And this is what I was hoping they were going to test here. So remember, we said that this is a unidirectional relationship. So let's go to PCA. Let's pull the command prompt up. And remember, that worked, but when we pinged an SSH, that all worked before, right? So can I ping? Is that what they're asking for? Let me double check this. Yeah, ping, or I'm sorry, from R2. Let me make sure I get on the right. Oh, they want us to do the web browser. Sorry about that. So from, or no, I got lost here. Close browser. I'm down here. I apologize. So from PCA, ping PCC. So I was right. So they want us to ping. So we'll come back and we're going to say ping 192.168.3.3. And again, we should see that these are not being allowed back through, right? You can see that the request is timing out because it's a unidirectional relationship. Traffic from the source inside is allowed to go through, right? But traffic coming back, or I should say traffic originating from outside, is not allowed to pass through that outside zone. Okay. The ping should fail. So from R2, can I ping? And this is going to be interesting, right? It says the ping should fail. So here we are on router 2, and oh boy, I forgot it's going to be Cisco Con PA 55. All right, let's see if we can just ping from right here, 192.168.3.3. And the ping fails. And again, it should fail because It's traffic originating outside of my environment. It's not originating in the inside zone. It's originating in the outside zone. So last thing that we're going to take a look at here, what if I were to ping, let's say ping, and what is the IP address of that serial interface on router 3? And this will be the segue into the supplement video, 10.2.2.1. Now that's interesting, isn't it? Because I just told you that I can't ping PCC, but I can ping router 3. In fact, I can ping the router 3 interface, which is a member of the outside zone. So how is it possible, and I'll leave this point for you to think on, how is it possible that I can ping the outside interface of router 3, which is a member of the outside zone, which has no unidirectional policy set up to allow traffic to come through? And I'm stressing that word through there, right? No traffic is allowed to be originated from the outside and go through router 3. But I can ping router 3. But I can't ping PCC. Why not? So food for thought, right? Food for thought. So think on that. And we're going to wrap up this activity right now. The supplement will answer that question, and it'll also show you that CBAC didn't have a convention for this. All right, that is going to wrap up Packet Tracer Activity 4.4.1.1 on Zone-Based Policy Firewall. Remember, very important, the syntax is much different. It uses the same inspection engine. It uses that modular quality of service command line interface, or the MQC. It's not interface-based, it's zone-based. That's why we've got that name, right? That's sort of aptly named Zone-Based Policy Firewall. All right, guys, thanks for watching, and I'll talk with you soon.